True Projects. In this video, we are going to discuss about the project which is oil spill detection technique with automatic updating using deep learning and oil spill index. So before getting into the execution, let us understand what is the project about. Normally in any oceans, seas or coastal areas there is a problem. And that problem is if any oil tanker or any cargo ship, if they spill out the oil into the water that may be accidentally or wantedly, they releases a chemical called liquid petroleum hydrocarbons, which is very harmful. Not only this, the oil will spread in the water surface and that forms a sticky layer that will block oxygen and sunlight into the water. But the animals and the fishes and the plants under the water, they need oxygen and sunlight to survive. With this blockage, they don't receive the oxygen as well as sunlight and they die. And not only this, if any fishes or birds, if they are covered with the oil that is spread on the water surface, if they try to swim or if they try to remove that oil from their body, they may swallow the toxic oil and that causes sickness to them or else they may die. And it has not only affected the aquatic environment, but it has also affected the livelihood of the people who depended only on this fishing. So, in this project, we are going to develop an efficient system that will effectively and accurately detect the oil spill. With that, a rapid response can be taken and prevented. In the existing system, faster RCNN, SSD, and RetinaNet, these were the algorithms that were used for detecting oil spills. But they had the limitations that are faster RCNN, though it had two-stage approach, it still they could not detect the oil spill in real time. And the SSD, it could not detect the small objects, also RetinaNet. So to overcome those limitations, in the project, we have proposed the algorithm called YOLO, which is You Only Look Once. It is an real-time object detection algorithm for detecting oil spill detection in this project. We have evaluated all the versions of the YOLO built in the project using mean average precision, and recall to see how the models are performing. This project not only benefits maritime authorities, coastal communities, industrial reliance, it will also benefit the aquatic environment. To implement this project, we need software and hardware requirements. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need Windows operating system, i5 and above processor, 8 GB and above RAM, 25 GB and above hard disk. As we have proposed YOLO, we built various versions of the YOLO to select and compare the best YOLO version. So first we'll know what is this YOLO. YOLO, it stands for You Only Look Once, which I've mentioned you earlier. It is a state-of-the-art object detection algorithm that processes images in real time. And it provides a fast and efficient method for identifying objects within them. It operates by dividing the input image into a grid and predicts bounding boxes and class probabilities directly from within the grid. Unlike traditional object detection methods that require multiple passes over an image, YOLO performs detection in a single pass, directly predicting bounding boxes and class probabilities for multiple objects simultaneously. This approach makes YOLO particularly well suited for applications requiring real time processing, such as autonomous driving, surveillance, and in this project for oil spill detection. Although all versions have similar objectives, they differ in their architectures. Coming to YOLO v5, YOLO v5 uses CSPD Darknet 53 backbone for efficient feature extraction, PANNet NEC for feature fusion at different scales. YOLO v6, it prioritizes even faster backbones and simpler NEC structures compared to v5 for real-time needs. Specific details are disclosed. Coming to YOLO v7, it builds upon YOLO v5's architecture by incorporating elements of both speed and accuracy. It involves modifications to backbone neck and head for this balance. The last one is YOLO v8. YOLO v8 it explores anchor-free detection for faster and more adaptable object localization. As YOLO v5 is performing well, we deployed it in the front end and detected the oil spills. Now we will execute the project. To execute it, first we have to open the code folder which contains source code files. So this is the code folder of the project. Now let's understand how each file will be used in the project. In this YOLO V5, we have the data set. So I'm opening it. Here we have three subfolders that are train, valid, and test. In train, we have two more subfolders that are images and labels. In images, we have images related to oil spills in the oceans and seas. So we use all of these images to train the proposed algorithm. So now get back. I'm opening labels folder. Here we have files containing annotations and the labels for objects in corresponding images. So each file, it corresponds to an image in the image folder. So for sample, this file, it corresponds to this image and it provides a detail about object locations and classes within this image. I'm getting back and opening the labels folder again. So all these files, they follow the YOLO format. So I'm opening one file. Here, each line, it represents the detected object. And wherein each line, it specifies one object class index, followed by its bounding box coordinates that are normalized to image dimensions. And those dimensions are x limit, y limit, width, and the height. As this label file, which corresponds to image file, has 6 oil spills in it, so here we have 6 object class indexes along with the bounding box coordinates. So here we can see 6 object class indexes with their bounding box coordinates. So now close this, get back. Similarly, we have image folder and labels folder in test folder as well as valid folder. So this train folder, which has images in it, those images will be used for training the algorithm. We use valid images to fine tune the models for optimal performance. And we use test images folder to evaluate how well the models perform on unseen data. I'm getting back to the main code folder. Similarly, we have the dataset folders in YOLO V6 as well as YOLO V7. Each folder contains the same images, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders helps keeping the dataset organized and ensures that each YOLO version receives the correct annotations it needs to function properly. And in the sample folder, we have the images. So we use this all images to test them in the front end. So get back. Coming to static folder, it contains files related to project styling and interactivity. It includes CSS, JavaScript, and Bootstrap files. These files are crucial for enhancing visual appeal and functionality of the project's web interface. Coming to templates, here lies all the HTML pages used in the project. They are index.html, about.html, etc. Each HTML file represents a different page of the website and they provide the structure and layout for displaying content to the users. This is the app.py file. This file is a Python file that encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content that to be presented in HTML templates. This is the model file, which contains the algorithm information, and that is loaded into the project's code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file used to store the user information. Now, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, now we need to paste the copied path. So I'm pasting the copied path and now click on enter. This will change current directory to the code folders path. So here we can see current directory is changed to the code folders path. Now we need to compile app.py file so that I'm giving the Python space app.py command and now click on enter. This command will execute the Python script and it will perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is localhost and the port. This is the localhost and this is port, unless configured differently. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. So I'm pasting the link here. Now click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So first we need to sign up. Click on sign up link and enter all the registration details if we are registering newly. I have already registered and have an account in it, so I will directly sign in. So click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. Now click on login. I have logged in successfully and I'm redirected to prediction page. Here we can see a choose file button. We need to click on that for uploading the images. So click on choose file. These are the images in the sample folder. So we use these images for testing in the front end. So I'm going to upload the second image. Click on open. Image has been loaded. Now click on upload. We can observe that the application has detected 3 oil spills in the image and a red color bounding box is drawn around the oil spill. During the training phase, various features like multicolor analysis and texture assessment of the water surface there were used for detecting oil spill. So in this front end, the application first analyzes multicolor patterns and textures and then draws a bounding box around the oil spill. Here we can observe a red color bounding box is drawn and it is labeled as oil spill with a 0.98 probability score. Probability score is nothing but it is a confidence level, that is how accurate the detection is. So now we will try uploading some more images. Get back. Click on choose file. This time we'll be uploading this image. Click on open. Image has been loaded. Now upload it. We can observe that there are 5 oil spills detected. Here we can observe oil spill is detected. Here also we can observe oil spill is detected. So there are 5 oil spills detected in this image. Generally, it will detect oil spill when there is a color change, that is, it looks multicolor in the water, or where there is a thick layer in the water, then it detects the oil spill in the water bodies. Now we will try uploading some more images. Get back. Click on choose file. This time we'll be uploading this image. Open it, upload it. Here we can observe there are multiple oil spills detected. Here is the oil spill detected. Here we can see. And a red color bounding box is drawn around the oil spill with their probability scores. Now we will try uploading some more images. Get back. Click on choose file. This time we'll be uploading this image. Click on open. Image has been loaded. Now upload it. Here we can see that multiple oil spills are detected and a red color bounding box is drawn around them. Here we can see a color change in the water body. So here we can see oil spill has been detected. Similarly here, there is red color, that is multicolor in the blue color ocean. Similarly here also. So now we'll try uploading some more images. Get back. Click on choose file. This time we'll be uploading this image. Click on open and now upload it. Here we can observe there are oil spills detected. So here we can see oil spill is detected with 0.99 probability score. That is, it is very accurate. Here we can observe oil spill is detected. Wherever there is color change in the water, we can see oil spill is detected. See here we can see multicolors that are blue, green. When oil is spilled into the water, the color gets changed. So based on those features, spill will be detected. Now get back. We tried from the test cases folder. So now we will try uploading images from the Google and see how will it detect the oil spill. So open a new tab, oil spill images. So here are the images of the oil spills. So I'm going to download this image. So I'm saving it. We will try uploading this image in the web application. So click on choose file. I have saved it in this folder. I'm uploading this image, which we have saved from the Google. Image has been loaded. Now click on upload. Here we can observe oil spill is detected from the uploaded image with a 0.85 probability score. That is, it is accurate for 85%. So now we will try uploading some more images from the Google. So get back. I'm opening Google again. This time we'll be downloading this image. I've saved it. Get back to the application. Click on choose file. As we have saved this file, click on open and now click on upload. From the uploaded image, we can observe oil spill is detected with a 0.91 probability score. We will try some more images from the Google. So get back to the Google. This time we'll be loading this image. So I'm saving it. Get back to the application. Click on choose file. So I'm uploading it as we have saved it from the Google. Click on open. Click on upload. Here we can see where there is oil spill in the water body. Oil spill has been detected with a 0.775 probability score and with a red color bounding box. Now we will try uploading some more images. Get back. Go to the Google. This time we'll be loading this image. So save it. Get back to the application. Click on choose file. As we have saved this image, we will upload it. Click on open and now upload. Here we can see there are two oil spills detected with the red color bounding box around them. As there is oil spill in the water, so it has detected oil spill in it. Get back. We'll upload some more images. So get back to the Google. This time I'll be downloading this image. So save it. As this is not the JPG file, it will not work. So I'm closing it. We'll try using some more images. We'll download this image, save it, get back to the web application, click on choose file. As we have loaded this image, we will upload it, click on open and now upload it. Here we can observe there is oil spill detected with 0.89 probability score. Get back. In this way, just by uploading images to the system, it will detect oil spill from the image. Now we will see the comparison graphs of the project. So click on graph. So here we have precision recall graph, where on x-axis represents recall score and y-axis represents precision score. This is precision recall graph for the YOLO V5 algorithm. And here we have FN score graph, that is FN score confidence curve graph, where on x-axis we have confidence and on y-axis we have FN score. This is for YOLO V5 algorithm. Moving on, this is confusion matrix of YOLO V5 algorithm. And this is precision score comparison graph, where on x-axis we have precision score and on y-axis we have all the algorithm names. Precision, it is a metric that measures the accuracy of positive predictions made by a model. It is calculated as the ratio of true positive predictions to the sum of true positives and false positives. From the graph, we can observe that YOLO V5 is performing well, so we have deployed it in the front end. Moving on, we have the same graph here. Here we have mean average precision comparison graph, that is MAP. On the x-axis, we have MAP score for each algorithm, and on y-axis we have algorithm name. MAP, which is mean average precision, it is a metric that commonly used in object detection tasks. It calculates the average precision for each class and then takes the mean across all classes. Average precision, in turn, is the area under the precision recall curve. So here are the comparison graphs of the project. Now click on sign out.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.